Images formed by convex lens. Objectives: to study the nature of image form due to a convex lens, to see its practical applications. For the sake of simplicity, in studying about the images formed by a convex lens, we will use a linear object like a candle, kept perpendicular to principal axis of the lens. A ray emitted from top S of the candle travels parallel to principal axis and reaches the lens at point P. Then it deviates to pass through the focal point F of the lens. Another ray from the top of the candle passes through optical center O of the lens and travels straight to intersect with the previous ray at a point S'. An image is formed at this point, where two rays coming from the object intersect each other. Hence, we have seen how an image is formed in a convex lens. But the image of an object changes depending on the object's distance from the lens. Firstly, when the object is positioned at an infinite distance, rays coming from the object will be parallel to each other. These parallel incident rays can be of two types. 1. These rays can be parallel to principal axis of the lens. And 2. They may not be parallel to principal axis of the lens. In the first case, parallel incident rays, after having passed through the lens, get converged to intersect at principal focus F on the other side of the lens. Due to this, a real, inverted, and highly diminished image is formed at the focal point. This type of image formation can be seen when we use a magnifying lens to burn paper. When parallel rays from the sun undergo refraction, they can be converged at principal focus on the other side of the lens, and when the radiations of sun are focused onto a paper kept under the lens, it gets burned. Next, in the second case, parallel incident rays from the object do not converge exactly at the focal point, but at some point S' in the focal plane on the other side of the lens. And due to this, real, inverted, and diminished image is formed at the point S'. This type of image formation is used in an astronomical telescope, where parallel rays from a distant object, after passing through convex objective lens, get converged at its focal point. Secondly, if the object is positioned somewhere between infinity and twice the principal focus 2f1, then incident rays from top S of the object, having passed through the lens, get converged at a point S' between f2 and 2f2 on the other side of the lens. Here, the image is real, inverted, and diminished. This type of image formation is used in a camera, where the rays coming from an object, which is not very far, pass through the convex camera lens converging at a point between f and 2f on the other side of the lens, and passes on to the photographic film. Hence, the image gets captured onto the film.